Comparative Study of Pre-Engineered Building and Truss Arrangement Building for Varying Spans. Roshni Ramakrishnan, Department of Civil Engineering, Data Meghi, College of Engineering, Navi Mumbai, 400,708 India. Abstract steel has been gaining massive popularity over RCC due to the very advantages it offers, like malleability, reusability, fire resistance and so on. Pre-engineered building is a type of building system which employs built-up sections for the structural members which are engineered and manufactured at factories and assembled at site. This results in good quality control and saves a lot of time. Study of past research shows a lack of research on the effectiveness of pre-engineered building system for smaller and larger span buildings, and also most comparative study works in the past are between PEB and conventional steel buildings. For the research work, 3 plan dimensions 15x30m, 40x80m, and 90x180m for an industrial pitched roof building are considered and each checked for a PEB and truss arrangement building configuration, and a detailed comparative study is done. A comparative study of analysis results, deformations, and material takeoff is done, and subsequently the effectiveness of pre-engineered building for a building of given span and size is checked. Keywords: pre-engineered building, truss arrangement building. Introduction. Statistical data has shown that pre-engineered buildings have shown a reduction in steel in range of 20 to 30% and time saving of 30 to 50% and has become a preferred choice over the past few years. The advent of computer-aided design has made it possible to come with customized design as per requirement. Primary structural elements of PEB are: PEB2. 1. Purlins and girts support roof and wall sheeting respectively. They constitute 10 to 25% of total steel. 2. Eaves strut supports gutter. 3. Bracings are used to give longitudinal stability. 4. The lateral stability is given by frame structure as shown in figure 2. Literature review. Beadle et al., 1973, explained the need for ways other than resizing the members for optimization. Some of the techniques for optimization suggested are: 1. Use ways to capitalize strength and ductility. 2. Exploit the potentials of load factor and limit states of design. 3. Consider stiffness contribution of walls, partitions and floors acting with structural frames. 4. Utilization of additional strength that can be exploited in biaxial columns. 5. Interior beam to column connection need not have stiffeners. 6. Going for optimal geometric configuration. Ajiz Ahmed et al., 2013, carried out a comparative study between PEB and conventional steel frame building. The following conclusions were deduced. 1. PEB gives lighter sections and hence effect of seismic forces is reduced. 2. It was deduced that for building of length 80m with columns provided at 8m, 8.88m, 10m, 11.425m and 13.3m, 8.8m and 11.425m gave economy. 3. It was observed that 27% reduction in steel took place. 4. In case of long span structures, PEB gave more economy. 5. Weight of PEB depends on bay spacing, with increase beyond a certain limit increases weight of steel. Kavirao et al., 2014, carried out a comparative study between pre-engineered building and conventional steel building. The following were the observations. 1. PEB reduces steel used by 36% than that required by conventional steel building. 2. The analysis forces are lesser in PEB as compared to conventional steel building. 3. Since the reactions in PEB are lesser due to lighter sections used, foundations are comparatively lighter. 4. Delivery time is as follows. PEB 6 to 8 weeks. CSB 20 weeks. 5. 30% cost reduction was observed in PEB as compared to CSB. Pradeep et al., 2015, took up the study of various types of roof trusses like Warren, N, Pratt, and Howe truss systems. It was seen that the Warren truss is most economical among all. Anil V. Bandra et al., 2019, carried out a study to compare design using hot-rolled steel section and built-up sections. It has been concluded that the shear force bending moment and displacements are comparatively lower in PEB than in using hot-rolled steel section. Umesh L. Mali et al., 2020, carried out a comparative study between various lateral load-resisting systems for varying heights. The following conclusions were deduced. 1. For buildings in the range of 20m to 35m height, shear walls are efficient. 2. For buildings in the range of 20m, X bracings are efficient. 3. X bracing is most efficient in high seismic zones. 4. Concrete outrigger system is more efficient than steel. 5. UL shapes are more critical. 3. Modeling and analysis. A. Skeletal modeling. STD.Pro Design Software. 1. Spans of 15x30m, 40x80m, and 90x180m are considered. 2. A uniform height of 7m and base spacing of 6m is considered for all models. 3. Hinged support is provided at base as it helps to get an optimal structural design. B loads. 1. Dead loads. Self-weight and a multiplication factor of 1.15 is taken to account for weight of connections. Calculations. A. Roof loads. 4. Procedure for analysis and design. 1. Collection of data for the proposed model, span of building, location of building, initial proportioning of building as per client specifications, wind and seismic parameters as per IS code. 2. Modeling instead and applying the loads calculated as per codal specifications. 3. Optimization is done so as to arrive at an economic structural configuration. 4. Extract the results required for comparison. V. Certicability checks. As per Table 6 from IS 800. 1. For rafters permissible deflection is span/180. 2. For columns permissible deflection is span/150. 6. Results. 7. Conclusions. The major objective of this study was to carry out a comparative study between pre-engineered building and truss arrangement steel building for varying spans and hence arrive at an economical configuration for a given span. The results obtained are summarized as follows. 1. PEB is found to be more economical than CSB for mid and large span industrial building structures in the range of 40-90 m. There is seen to be an increase in steel consumption in CSB as compared to PEB for the 15 m building. 2. The size of steel cross-sections was greatly influenced by the serviceability requirements in CSB models. The CSB model for 90 m, large span building, showed great joint displacements and greatly influenced the member section sizes, hence giving comparatively lesser economy in steel takeoff as compared to PEB. 3. Due to the rigidity of the joints, PEB model members carried lesser forces than CSB, and also due to the variation of member profiles along the length, there was more economy in material in PEB than in CSB. But in small span building 15x30m the CSB had lighter members and hence was more economical.